All right. So this question would not take as long if I wasn't going to go back and show you by hand the review stuff. This is stuff you already know how to do. So don't, how weird is that? Y'all can hear me, right? Zoomers?
Yeah, we can hear you.
Okay. All right. So again, this wouldn't take as long as if I didn't want to have to go back and review. Again, you already know how to do it. I just want to review how to do it by hand and how to do it in the calculator. It takes like 2 seconds in the calculator, but I'm going to review by hand as well because you need to know it. All right. So the first thing that you're going to do is state the distribution. And values of interest. So why did I write it like this? What does that tell you when you get something like this? What's the end tell you? Just the end. What's this represent? Anybody? Guys. We're going to be in trouble. This is why we're reviewing. This is why this problem's going to take a little bit longer. What's it say right here? N represents normal distribution. Might want to write that down. What are these two numbers? Zoomers, what are these two numbers? 68 and not 68, 64.
It's the mean and standard deviation. That's why I was confused. I know why you're choosing 68.
Yep. Just yell at me. 64 and 2.7 are your mean and your standard deviation. So that lets you know that you can use normal functions on your calculator. You know what I'm talking about? Remember your normal CDFs we used on our calculator? That's what this problem is. It's a normal CDF problem, but we do it a little bit different. 64 is your mean and 2.7 is your standard deviation. So then the probability we're looking for, and you guys need to be able to write this, is what? What goes inside that parenthesis? If we want heights between 68 and 70. Think back to yesterday.
Would it be 68 is less than or equal to y is less than or equal to 70?
Why'd you use y?
Because the problem said call her
problem
height.
said y. Yesterday they said x, so we use x. So watch what they put in that problem for you. The second thing that we're going to do is calculate. Again, I'm going to show you how to do this by hand. That's the crappy way. And I'm going to show you on the calculator. The problem is when you take your AP exam, they would rather you do it by hand. Remember, if you do it on your calculator, you write everything down. Okay, write everything down. So here's what we're going to do by hand. To be able to do it by hand, this is just a review. I'm not asking you to do it right now. We have to find our z-scores. We have to change these to z-scores so that we can get our probability. So remember, to find the z, what's our formula for finding z? Yes, observation minus mean over standard deviation. How many observations do we have? 2. We have 68 and 70, right? You're all right. Observation minus the mean over the standard deviation. But I also have the 70 as well. So I got to do both. So think back to when we did this. I will go ahead and tell you that gives you 1.48. And this one gives you 2.22. So then to find your probabilities, you go to table A and you look for 1.48 and you find the probability in the chart. I wish I had them, I do have them printed up there, I think. My charts are hard to find in my book. All right, so 1.48. Here's 1.4. And then 8 is all the way over here. So 0.9306. You guys remember doing that? Okay, same thing, 0.9306. I wanted to show you how to find that. This one is going to be 0.9868. And if I want to find that range, what do I have to do those two numbers? Subtract them. So I'm going to take the big one, subtract the little one, and it's 0.0562. That's my answer right there. If I do it in the calculator, we did the n because we said normal. It's going to be CDF. So where do we find that at? Where do we find that in the calculator?
Isn't it under stat? See why we're reviewing? Second bars. Second bars. Everybody good? We have normal CDF. It tells us a lower and an upper. Remember, if we don't have a lower and upper, say like we had greater than or less than, we would put ridiculously large or ridiculously small numbers, but we have both of ours this time, right? So what's our highest height we can get? I mean, our lowest height we can get? 68. What's our highest? 70. What's our mean? And then our standard deviation. Remember, we do this so we don't have to do the z-scores or anything like that. So it'll do all that for us. So just make sure that you write that down. Lower is 68. Upper is 70. Mean is 64. Standard deviation is 2.7. And when we paste it in, sorry, y'all, it would help if I was not in there. We get the same thing. Okay. Is everybody good? Which one's the more accurate one? Is that supposed to be 0.0?
Yeah, I just didn't write it down. Which one's the more accurate one?
The calculator.
The calculator, because we didn't round at any point in that. Remember, the table A rounds things. So then 3 says, what's the probability that the randomly chosen woman has a height between 68 and 70? You have to write it out. There's a 5.6% chance that a randomly selected, in context of the problem, young woman has height between 68 and 70 inches. And then one more little paragraph and we're done. In your homework, I don't care whether you do it by hand or with the table, but I would try like at least once or twice, try to do it with the table. Like you can do it by hand on your homework, but then see if you can do it. You can do it by calculator on your homework, but then go back and see if you can do it by hand and get the same answer. So that way you know know how to do it. All right, last little paragraph. The calculations in the preceding example is the same as those we did in chapter 2, only the language of probability is new. What about the mean and standard deviation for continuous random variables? The probability distribution of a continuous random variable is described by a density curve. Chapter 2 showed how to find the mean of the distribution. Remember, it was the point at which the area, sorry, I can't spell, area, under the density curve would balance. I don't know if you guys remember those pictures. They were like you had a right skewed or a left skewed, and they put like a little triangle at like the balance points. So that's kind of what it looked like. So if they were made out of solid material, the mean lies at the center of symmetric density curves, such as the normal curves. And we always want to work with normal And you'll learn that later on, that we always want to work with normal so that we can do calculations. So we'll end up making skewed into normal curves. We can locate the standard deviation of a normal distribution from its inflection points. Sorry, y'all. Exact calculation of the mean and standard deviation. For most continuous random variables requires advanced mathematics that we don't get into. And that is it. I don't think I've opened up your quiz yet, so I got to do that. I'm going to stop sharing and stop recording.